Hello, GrafanaCon. I'm Jonan, and I am coming to you from Portland, Oregon, with a drone flying over the city and over a sign carrying one of these Raspberry Pis. And that Raspberry Pi is connected to this mobile router, and that mobile router is connected to the rest of the Raspberry Pis here that were strapped around my neck on the ground. And they were running not a Kubernetes cluster, as in the title of the talk, but a Docker swarm. It turns out that Kubernetes does not run on the Pi Zero. It is possible, but it's not an easy thing. And I have many Pi Zeros. I have a few Pi 4s. I think in total, I probably own 25 Raspberry Pis. So I have something of a problem in that I buy too many Raspberry Pis, and I have another problem in that I thought it would be a good idea to install Kubernetes on them. So I'm going to walk through what it takes to install Kubernetes on Raspberry Pis, and we're going to build them together. But first, I want to show you one more video, and that is my cluster actually running. So let me shut this down real quick, and then I have another one right behind it of the drone, again flying here. Now, I don't want to give you the impression that this video is coming from the Pis or anything. The Pi, it's really just a zero strapped to the top of the Pi, and it has no function as of yet. But I did use it to see how far away I could get from the mobile router the other day and maintain my SSH connection, and I got 250 feet up in the air, as you saw. So this is a video of me on the bridge with my kids the other day, and I have a Pelican case in front of me there that you'll notice does not have any wires on it. And inside of that Pelican case, I have a little more robust Kubernetes cluster that you can kind of see in the background over here. My camera situation is not ideal, but we're doing what we can. And if you look carefully now, you'll see that I've got a keyboard out of my Pelican case, and it says, "Hello, GrafanaCon." And that was our last take when we had some visitors come directly in front of the shot. I'm a hell of a filmmaker, ladies and gentlemen. So, without further ado, let's start talking about some nerd stuff. My name is Jonan. We don't want to look at this, because this is a lot of code, and you'll just read the code and not listen to me. And I have so many cameras set up to talk to you about Kubernetes today. This is me. I'm the Jonan Show on the internet. And you should come and find me if you are interested in watching me tweet silly things about silly robots. That's a pretty good one. So I mostly talk about these things on Twitter, and I have a GitHub account that is filled with half-built and broken projects. I would not recommend you run any of the code on that website. And but you're welcome to dig through it. I think I have something like 200 repos now from all of the demos that I've put together over the year, all of the talks that I've given. This is, I think, by far the most ambitious that I've ever gone through. So to give you a little background, I 2 months ago knew almost nothing about modern container orchestration. I worked for a really long time at this company called Heroku that some of you may have heard of that does cloud deployments. And the funny thing about working for a company like that is that you have infinite free cloud services. So why would you ever learn to do these things? I mean, the container thing, I dabbled in containers because we actually allowed you to run Docker containers on our platform. But I certainly never had any reason to install Kubernetes from scratch. And I started looking around online, and I thought, oh, there's like tutorials, and Raspberry Pis are awesome. I own a lot of Raspberry Pis. I'm going to make a Kubernetes cluster out of it. And I had no idea the can of worms that I was about to open. There's a lot of complexity in Kubernetes and in Raspberry Pis, and combined all together, it makes for an interesting experience. But if we don't get started actually installing the operating systems, we are installing from scratch on these Raspbian SD cards. And I'm going to prove it to you because we're just going to actually put them in here. I've got a little drive, and I'm just going to install this in my drive and put it in my computer, and I'm going to burn it with Etcher that you can see up in the top right. So this is I'm going to actually use one of my 32s here. I've got a 32 gig drive, and upgraded. There we go. We're going to put that in there, and then I'm going to go ahead and burn this. And while that's burning, I'm going to talk to you a little bit more about the project. We're going to throw away the Jonan show for now, but that'll be back. I'll remind you later. Okay, so while we have that up in the top right, you'll see Balena Etcher popped up. Balena is a company that does a lot of stuff with container technology. You may have heard of them. It may be Balena. I'm not positive. I do know that people in the Kubernetes community really don't like it when you call it kubectl or any number of other things like K8s. We're going to use a tech called K3s today, which is not actually called K3s, probably. I think people call it Rancher, which makes a lot of sense. And I call it Kess, like the woman from Star Trek, the probably least popular Star Trek of all time. But we're going to use that, and we're going to use a tool called Ketchup to install the Kubernetes cluster. But first things first, let's go ahead and flash to our drive here with Etcher. So I've just got a Raspbian downloaded here. This is the Raspbian Lite image. For some reason, it'll usually break on the first burn and then pop up on the second one. I think it's a permissions issue because I've been burning SD cards every hour of every day for months. Yeah, okay, let's try again. The second time it always works. But I am not sure what I have done to generate this failure mode, and frankly, I don't have time to care. Okay, so this is the Raspberry Pi we're going to be working with today. This is a Raspberry Pi 4, and I've got a heatsink wrapped on it here. That is a handy little case, comes with a couple of fans, and you're going to want these cases. You probably want to overclock your Pi. They, in my case, I've overclocked them to 1.5 gigahertz. People take them up to 2.1 sometimes, but that's about the upper bound. And then you need to watch your temperatures very closely. So in order to get started with a cluster, you really just need this for a master node, and then you need to have a couple of secondary nodes. And the Raspberry Pi itself, the case, the SD card, are most of it. There is one note about the power supplies for Raspberry Pis. So the Raspberry Pi 4, when they came out with it, they have USB cables, right? These fancy USB cables, and the kind that you have like with your Mac, right? Or whatever you own that has a USB connection on it. They have an eMark in them. There's a special type of chip in the tip of this that detects whether or not it's officially compliant with X standard, and it helps to downregulate voltage and things like this about plugging into the outlet itself. So it actually detects things inside of the USB-C outlet. So long story short, the Raspberry Pi implementation of that technology is flawed. Rather than using 2 resistors, they used 1 because they thought, well, this diagram for this PCB could be so much simpler. I could just use 1 resistor and it would accomplish the same effect. And they were incorrect because it means that the good, expensive USB cables don't work with the Raspberry Pi 4s. So cheap out when you go to buy your cabling. So you're going to need a Pi. You need the case, definitely a cooling case of some variety. I like these ones. They're pretty nice. Then you'll need a small switch if you're going to run a cluster. I've got a little 5-port switch here. And the power supplies themselves. So the power supplies need to be supplying at minimum 3 amps to each of the USB ports. You'll be very tempted to buy something like this, these big bricks that have all of these. But if you look very carefully at the specs on these, I couldn't find one for sale that had 3 amps out of all of the ports. They mostly are 2.4. And I did find a couple of bricks that have just 2 ports at 3 amps, and so I'm running 2 of those on this here. So we've got the Raspberry Pi, and we have burned our image, and while that is happening, we're just going to get started right away burning another one, because we have one little bit over here to do. So the Raspberry Pi card boots up with just this Raspbian Lite image, and then there's a fair amount of setup. that has to take place in order to get from here to a Kubernetes cluster. One of those pieces is that we've got to enable SSH. So I'm going to go over to my volumes here, and I'm going to touch this SSH file. Or sorry, over on the boot, right? Why not mount it? I have to pull the card out and put it back in again. Ready? Here we go. I've been doing this just on loop for days, just days and days. And today I had an exciting variation on the plan, which is I rolled over my master image with my chair. Yeah, this is one of the bits of advice I have for you. In setting up your own Raspberry Pi cluster with Kubernetes, don't run over your SD cards that you need to clone. Okay, so we have over here on volumes boot. This boot volume can be used to manipulate the Pi in very tiny ways. You can't just like drop scripts on there and run them or anything. You can actually, if you modify there's a command line file that's loaded up, and you can modify the init tag in that and run scripts arbitrarily. But it's kind of a bad idea because it boots up at times you don't think that it boots up. In any case, there's a lot of stuff that you can do to rescue your Pi when things go wrong with this boot volume that is mounted when you put the SD card in. And one of the things that you can do with it is you can tell it, if you find an SSH file anywhere on here, it doesn't have to have anything in it, but if you find an SSH file, go ahead and turn on SSH when you start up. So then I'm going to go and use my disk-util to unmount this. Disk2, okay. And we pull that one out, we get another one in there, we'll start burning that. And I'm going to get this one all plugged in while we do that. So the other piece to this is that between here and being able to run the installer, we're going to be using a K3SUP ketchup installer, courtesy of one gentleman named Alex Ellis, who makes a lot of great tutorials on how to install Kubernetes on Raspberry Pis. And I highly recommend all of his work, actually. He was really helpful to me. I got stuck on Twitter the other day trying to follow the instructions in one of his tutorials to get started, and being confused about what it was I was trying to accomplish. The way that you expose a pod once you deploy it used to be different. So Alex helped me out. And he does a lot of great stuff for the Docker community. You should go and play with his tools. He makes a ingress controller called the inlets operator that helps you if you want to just expose port, kind of like ngrok for your Kubernetes cluster. Then ngrok being a tool that does like external tunneling to an IP address. So if I have a local server running on my machine on port 3000 and I want to do some development work, then I can use ngrok to tunnel that out to an external IP address and send that to my friend and have them help me diagnose issues with the web app or what have you. So inlets operator is something very similar. You should go and check out the project. We have now this Raspberry Pi. I'm going to get plugged in over here. We're also going to be setting up a shared volume. So I've got a disk over here, a USB drive, that we're going to be setting up as a networked file share. So this is going to be all our database and everything. This is where all of our claims are going to go for all of the data that we store in our cluster. And I'll explain what that means in a little bit here, because I'm kind of assuming no knowledge of Kubernetes, although I know in the Grafana ecosystem there are certainly plenty of you who know it very well. I also know that there are probably a fair number of data scientists and other people who are maybe less well-versed in this kind of thing. I managed to operate in software for quite a long time, knowing very little about Kubernetes, and really it's all very new, as it turns out anyway. And you will see some of the news today. I would consider it a small miracle if we get even the dashboard to load right now. But we are going to go ahead and get this one booted up so we can make some progress here. Let's see. I'm going to get a monitor plugged in and a keyboard here. So in the background back here, you can see all sorts of nonsense lying about. I've got a bunch of Raspberry Pis scattered around. I've got a couple of Mac Minis that I'm trying to turn into part of the cluster. I've got my first laptop, the first laptop I ever wrote any code on, about 10 years ago when I became a developer. I mean, I'd written code before then, but I was a poker dealer at the time when I got into software. And that's a whole long story for another time. But I have to say something that doesn't take too much mental energy while I plug in keyboards and wires. Okay, here we go. And now we are booting up here with this Raspberry Pi. So as soon as we see the screen behind me light up, I hope, that means that our Raspberry Pi is going to be ready to go. Look, yeah, okay. Well, not ready to go just yet, but you're going to see a bunch of stuff back here. What it's doing right now is it's resizing the boot partition. So when you burn the image to the volume, when you burn the image to the card itself, it's going to burn smaller than the full capacity of the card. So as soon as the Raspberry Pis boot up, this is the nice feature of the more modern Pis, they'll go and they'll resize the volume so that you have access to the full disk space. So I put the 64 gig card in because that's going to be our primary node. And I had originally intended to use part of those 64 gigs for this networked file storage. But as it turns out, you don't need that much space at all to run these things. So we've got all of our volumes unmounted. I'm going to go ahead and run that code that I showed you earlier. That code was pretty savage to write, and it took me a long time to figure out how to attach my standard in and my standard out the right way to the actual Raspberry Pi so that I could do some intermediate provisioning. So there are a few things that have to happen when we start the Pi up. We need to get our SSH keys on there, right? We got to get our pub key over so we can log in with our keys instead of logging in with a password. We need to change the password because everyone complains about the password if you don't change the password. We need to set up that file share that I was talking about. And probably the most important, I think, for Kubernetes is we have to set up a host name. So you've got to go and edit the etc host name file and put your name for your host in there. And then you've also got to change it in the hosts file itself, so it points back to itself. And all of those steps are very difficult to accomplish without escalated privileges, And so most of the tutorials that you read and most of the scripts and stuff that exist out there, they just kind of hand wave through this part. But this is actually kind of a pain to go and do over and over and over again, right? Which is why you want to, first thing, get yourself one of these that's actually together and set it aside. Okay, so that you have an image of this, and you of course can just drop the images down from the cards. You can clone the images to your computer, which you should, but then keep a card around, because if you're able to just plug it in and clone it back over to the other cards, then all of the configuration step you get to skip the next time. So we've got one card in there. I'm going to run this. This is our provisioning script. And it's found this Raspberry Pi. It finds it just because anytime a Raspberry Pi joins a local network, it starts out as raspberry pi.local. And so this is raspberry pi.local. I want to use that IP. I'm going to enter our host name as drone0. Drone0 is going to be our primary node for our Kubernetes cluster. My password is GrafanaCON. Don't tell anybody. And I am going to share the file system, I hope. Warning, set locale. It appears to be doing the thing, but I'm not convinced. We'll see. If this script runs on the first try, that is a smashing success. And so far, so good. So we're installing, we're updating, we're doing the apt-get update, apt-get upgrade, and installing the NFS file server that we need on there. In addition to that, we are doing a lot of other things, I guess. I'm going to walk through this really too much code real fast, but there's the little prompting bits. This is the DHCP file, and that's where we're going to put in our IP address. We're going to tell it where we live on the internet. We're using this Ruby package called netscp, which is a little bit difficult to understand, but incredibly powerful when you brute force your way through it. It requires you to do things like use all of these string IO objects, but the upside of doing it this way is that you can do it all kind of at the same time, right? Like I would hesitate to call it asynchronous, but I am queuing up many things to download, and then I am downloading them all, and I'm still bound by the global interpreter lock that is in Rubyland. But I could probably get away from that at some point if I wanted to. The goal here was just to make it as fast as possible so that I had a reasonable chance of deploying a Kubernetes cluster live on a stage from a Pelican case that contained the entirety of that Kubernetes cluster and running on battery power. So we are editing the fstab file. It's not actually, it's the file system tab, right? Like cron tab, but for your file system, that's where we're going to expose this, this file share that we're setting up. We're editing the exports file. These things are not things that Linux likes you to do without sudo. And then also getting sudo and keeping it over a single SSH session where you change your password in the middle of it is a little bit complicated. And we've managed to do that. All we had to do was include a little Python in our Ruby. If you look closely down here on the bottom, I'm going to embiggen just to make sure you can see it. My point here is we can all just get along. Whatever you use to build your dreams is fine with me. Just go build stuff. It's fun. So we have this script. This script is uploading this DHCPCD. I always forget the C because I want it to be the DHCP daemon file. We have hosts, we have host name, and we have authorized keys, right? I'm pulling down the authorized keys from GitHub. Very convenient place to get your keys. If you have a GitHub account and you have your public keys uploaded up there, you can always just curl this your username.keys and get the keys. So I'm pulling them down, and then I'm copying them over to the temp directory and changing permissions around on the files as they need to, and going up to sudo and then forcing them all into place. And then in the end, we have a Raspberry Pi with a correct host name and a changed password and a mounted disk share. And then we should be able to reboot the thing and deploy catch-up to it. So while we have that one booting up, it looks like it succeeded, and it was much faster than I expected. I'm not remembering, did we already touch the, we didn't, because this one's not even up. All right. So we're going to go ahead and unplug and replug our SSD again, and then we're going to touch this volume, and then we're going to speed things up, because this is already taking too long, and I have so much drawing to do. I got the little whiteboard out. Giving talks at a great distance is complicated. It's going to take some effort to get used to it. My office is just packed full of cameras and lights. It's absurd. This is a very carefully chosen area of focus. Let's see. I'm going to touch this SSH file. The other thing you'll want to do with your SD boot partition that we're working with right now is put a WPA supplicant file on there so you can pre-configure your Wi-Fi network when you want to have Wi-Fi available. So while we wait for this other one to run, I'm going to go ahead and unplug this so it boots back up and it gets its new, I want it to get a new host name on the network so that when I put this card into a different one, it is no longer Raspberry Pi, which, as you can imagine, makes things more difficult. When you have multiple hosts that are called Raspberry Pi.local. So I'm going to pull this out, and we will get booted with our very first drone. So in we go. We've got another monitor cable. No, I don't. Oh, I do. But this one actually connects to the same monitor. This other one only connects to legacy Pis. So I'll put this one in here just in case we have to debug something. But we've got this and this and this. And we are missing only our power cord. Here's our power cord. Okay. So now we're plugging in the power on our second Pi. This will be our first little helper. And I'm going to go ahead and get the other SD card in there and do some more burning. Flashing another one. Ready, go. First flash is going to fail. I'm calling it now. How about you? I choose you, Pikachu. Cook that flash drive. All right, more passwords. Seems fair. Oh, maybe it's just going to go this time. Nope. Helena, if you are watching this, I love your product. It's just fantastic. Not sure what's going on, but I would love to help you debug that. If you want me to send you log files or anything, I would be happy to help you out. So now we have two of them online. And I've got my other SD card here ready to go for the next baking. So let's talk about Kubernetes and what this thing even is. right? What even is Kubernetes? I just want to walk through real fast. I know many of you know all about this ecosystem, but Kubernetes is a way to get containers up into the clouds, right? And not because you're silly and you strap a Raspberry Pi to your drone and fly it up into the clouds literally, although that's going to be pretty awesome. I'm pretty excited about the Docker Swarm. Oh, it has to use Docker because the architecture on these older processors, these actually only use ARM 6 on the Raspberry Pi Zeros. And there aren't very many images you can build for the ARM 6 processor. ARM 7 is what all of the Raspberry Pi 4s, that's the most modern Raspberry Pi, is using ARM 7. And it can actually use the ARM 64 architecture, but it doesn't because Raspbian doesn't enable it by default. They're still building the 32-bit operating system images. So most of the stuff that you're going to use out there is going to be using that anyway. So let's go over here and do some drawing of what even is a container. I have a really good analogy about containers, actually. This is an easy one to remember. That people always told me it's a recipe. It's like a recipe for what you want your server to look like when you deploy your application, right? If you wrote your Ruby application or your JavaScript application or your Python application, and your server doesn't care anymore. You just write a Docker file, right? And that Docker file wraps up your application, and it's a recipe for what the server should look like. But it's not really, because it's not a recipe like food, right? It's a recipe like space food. So imagine now, just bear with me here, those little ice creams. This is my art skill coming to light here. These, back when you were a kid, or when I was a kid at least, I know that some of you had this thing. This is like a little ice cream packet that was like dehydrated ice cream. And it said NASA on it. It was like space ice cream stuff, right? This is what you're building. You're building a recipe for dehydrated food. You're not producing food, right? And it's a special kind of dehydrated food where you can snap your fingers and rehydrate and dehydrate it again, right? Because this is going to be here, right? We have our recipe to build that thing, all right? And that recipe, that's our Docker file, okay? So this is the Docker file. And this dehydrated space food, that's an image. That's a Docker image that we're building, right? And the Docker image, when rehydrated, I'm going to change colors for the rehydrating process. I have like 5 colors, 6 colors. I got to get creative because Kubernetes has many components. But we're going up now, and now we go from an image to a container, okay? So the container, here's our bowl of ice cream, right? That's when we have rehydrated the ice cream. This is the ice cream in the, oh wow, this is really quite a lot of artwork. Yeah, that's good. Okay, that's our ice cream in the bowl. And this is our container, right? But now, again, this is just our recipe that we can share around, this image, right? And this image here is what's made from the recipe that says things like install Python, right? We want to install Python on the server, and also we want to have Redis, right? And we're also going to set some environment variable, okay? Don't do that in your images, by the way. They're hard to get out of your image history. When you put them in Docker files, this is not a great way to store secrets. If you want more background on that, go read some of the issues on the Prometheus project. They have a lot of feelings about how and when people are allowed to use environment variables. But they're ultimately right. The argument goes that you just should disallow users from ever using environment variables because sometimes some people put passwords in them. I am not of that particular way of thinking on it. I think it's awfully convenient to be able to configure a Docker container when your password is something like GrafanaCON because you don't care. Anyway, so we have this recipe here. We're installing all the things that we're going to want on the server, and those are just the dependencies of our application, right? That's our Docker file. And then we burn it all down into this image, this immutable, vacuum-sealed, packed-up ice cream that we can ship around the world and we can hand to our friends, and they can spin up our application. This makes applications portable for the first time, really, in maybe the history of computing. We can just bundle up anything It's not a question of having a language that compiles to such and such architecture anymore. We are fast approaching a time when you'll be able to run most things, most anywhere. And with the cross-compilation pieces that exist in Docker right now, like the buildx command, you can build binaries for ARM processors. And that's what I've been doing to do this work, right? So we flashed our other drive here, and I don't think that we have run the commands against what will be our first drone, and that's 7.5. So 7.5 is now online, and we're going to call this one drone 1. I guess this is our second one, and our password is going to be the same. Don't hack it. We are not going to share the file system from here because we're going to try and install, assuming we ever get this thing booted, in the remaining, I think, 10 minutes of presentation time that I have. We are going to try and install a operator to do this thing for me. But I got to finish the explanation of Docker before you have any idea what this does. So the container, right? We've got an image. We spin it up into a container. But this color change here indicates that when we kill this, right, we shut this back down again, this is just the same, right? This image doesn't ever go anywhere. Now, we can go up and down and up and down and up and down with the containers, but the image is immutable. Once we've built the image and we've shared it up to Docker Hub or we've sent it to the other developers on our team, that's going to stay the same all the time, right? This container is the bit that changes. So I can spin up a new Postgres container that I download. The Docker team maintains some of these containers themselves, so there's an official Postgres container maintained by the Docker team. I download that and I monkey about with it and change all the things inside of it. And then I can ship it back out there to the internet, but only if I then take those instructions and generate an image from them. That container itself, if I throw away the container, it goes back to just being the image again. So there's this ability to kind of declare code bankruptcy. You can play around with these tools, and when things get too hairy, you can toss it all away. This is one of my favorite features of any software product, the ability to uninstall easily. Please include that in everything you ever write. I tried really hard to make this particular script idempotent. It's really hard to be able to undo something like injecting like a hash into an the shadow file for the passwords. That's not easy. Oh good. We don't want it to move those, but it appears to have worked anyway. So that would be the fstab and the exports file. We skipped all of those because we don't want to move those ones. So now we have our second pi configured, and we are rebooting it. And now we are going on and up. We've got to remember to touch the SSH file, or this thing is not even going to be accessible. So let's try plugging it in and out again. I had some coffee over here earlier with my awesome mug. Where are you? Have you tried turning it off and on again? This is all you do with Raspberry Pis all day long, is turn them off and then turn them on and then reformat them because you screwed up the file system with your questionable Ruby script that does a lot of sketchy things probably no one should be doing. And I am touching again this SSH. Good. And then we still have to dismount and stick the landing. And we did it. Great success. All right, we are well on our way to a 4-drone Kubernetes cluster booting up here. So, all right, I think I'm going to really have to focus, though, on getting through my little diagram because it may be the only thing that I do in this presentation here before we run out of time. So I have here a cable for that. To power on, I'm not going to bother hooking up the monitor or the keyboard. Oh, I should. If you don't have your HDMI plugged in when you boot up, sometimes your video driver will not be enabled on your Pi. So make sure you do that first. Okay. Sooner or later, we'll see some Raspberry Pi back there. We've got the last drive going in and getting full of Etcher right now. We are flashing our last drive. Do it. Do it. First try. I know it's going to do it on the first try this time. It's going to be so awesome. I would actually cheer out loud. I don't think it's going to happen though. Come on, baby. One time. It's got to be something. So one of you knows why this is happening to me. It's something with me unmounting the file system wrong or something that I should know. Okay, let's continue with our analogy here. So we have our containers, and those containers are the rehydrated ice cream bowls, right? And again, we could just snap our fingers and turn them off, and then they just kind of sit there. But they don't ever rot, right? They aren't the same as the original space ice cream that we have dehydrated. That image will always be frozen in time once it's created with our Docker file, right? Unless we create a different one. So these containers, we can push them around and we can run them all over the place. And Kubernetes abstracts that one more layer to start with. And it comes up with this concept of a pod, right? Here's a pod. So imagine for a moment then you have a buffet, and we're going to have sprinkles over here. And now we have sprinkles to go along with our ice cream, and those two containers could be part of the same application, the same like kind of logical business unit, and it would make sense for them to live next to each other. They could have some critical piece of functionality that needs to be attached in this kind of sidecar approach, where these two things run inside of a pod. But by and large, we can conceptually think of a pod as just a thing, right? Whether it's one container or many containers, a pod is kind of the finite Kubernetes unit, right? We have a pod, okay? As in the pod people. And we're going to draw our pods like this here. Here's a little pod. There you go. And this has got some things in it, right? We've got some boxes in there, and those have little things, and it's got a little glass bubble on it. I know, I'm an artist. It's pretty impressive, right? So we're going to have a lot of these pods, and then we're going to have another one over here. And pretty soon it becomes clear to us that organizing these pods themselves, that's somebody's full-time job. But why don't we get a robot to do it, right? So we're going to have a way for organizing these pods, and that is the orchestration piece of Kubernetes. Kubernetes is what is called an orchestrator, right? And that is just the role that exists for Kubernetes to kind of manage all of these pods. I'm trying to think of a way that a pod becomes like an ice cream analogy. The analogy starts to fall apart a little bit when we get past the Docker world and out into the Kubernetes world. But maybe this is a restaurant where you have many pods, right? And now we have the concept of a node. And not the language, and not the language backwards, as in Dino, but, oh, we're going to have to throw away two pieces because I'm using Sharpies. But while we're doing that, I'm going to strap up this one here. Let's go and unplug it because I am just about at time. I think arguably over time, but it's a video, so you could watch it faster if you were that bothered by it, I suppose. We're going to touch this thing here, and then we are going to do that bit again where we are unmounting the bit. There we go. All right, unmounted and plugged in shortly. The plugging and the unplugging is pretty time consuming. Oh, one other thing to note, if you're going to use your Kubernetes cluster for anything that you want your data to stick around for, I don't particularly care because I'm just wiping my cards all the time, but you'll want to disable swap because SD cards get written to a lot more when you're swapping to them, and that is suboptimal. That is not one of the features of my cluster as of today. Let's see, I need to go ahead and get that command running before the other Raspberry Pi local comes online. 173. I'm very suspicious that that is the correct one because I feel like 4 should have come online first, but maybe I'm wrong. We'll find out, I guess. And it doesn't really matter. Our last one was drone 1, and this is drone 2, and so we have 0, 1, and 2. We are 0 indexed, as everything should be. There are programming languages that are 1 indexed. Come on. How long did it take you all to wrap your heads around that when you were learning to program? Don't do that to people. It's just mean. Sharing the NFS. No, we're not doing that. All right, here's hoping that bootstraps. Oh, I want to show... No, I was going to try and get these ones online for you to show off the Pi Zeros. But we're going to be a little light on time, so let's keep rolling with the analogy we have here. We have our orchestrator, and the orchestrator is not really a concept you need to be concerned with terribly. It's just what a Kubernetes is. Kubernetes is one orchestrator. There are other orchestrators. There's Kess, which is probably not called Kess, but reminds me of the little alien from Star Trek, and I like her. And there are a lot of these, right? Every person who wants to say the right buzzwords in the right marketing meetings, they've already named several different orchestrators that their company invented, and nobody's inventing very much, honestly. Like, there's a lot of innovation happening in the container ecosystem, but it's also a lot of like, I'm going to pick up that open source thing and I'm going to put my logo on it. And that's good. So we have the brilliant people at the CNCF and places like Grafana to thank for a lot of the code that exists and is being rebranded and re-dashboarded as proprietary products. Go software. But try and stick to the CNCF platform stuff. You'll be much happier with your life in general, I think. The Rancher stuff is great for Raspberry Pis because it's a very lightweight Docker engine to run the containers. It doesn't take up very much space or use very much memory. So pods, those run on nodes. I'm going to make our node shaped like this. Oh, you know what? That's not right. Yeah. I think the correct shape for, or the correct color for a node is green, just to make sure we're not confused with anything here. I'm just going to spell node out here for everyone. There we go. All right. Something went, no, that wasn't quite right. This is what I was looking for. Node. That's a node. And the node is going to have many pods in it, right? Remember our little alien pods? What color were the pods? Oh, here you go. This is a pod, and this is a pod. And these pods, they don't care anymore where they run. They don't care that a node is a physical machine or a virtual machine or one machine has many nodes in it, right? All we care about is that a pod goes in a node somewhere, right? And that allows us to be in a situation where when I get this all set up, if I get this all set up in a moment here, I'm pretty excited if this actually will work, but we'll see if I can deploy anything to it. I'm going to run the commands thing one more time. And we already got 173, but we didn't reboot it. See, but now here's the problem. I got to unplug one of them. I'm going to take a risk. Oh, I don't have to take a risk. I can just do this because I've got the monitor plugged in. That one is the one because we stuck. So when we do the very last command, it sticks the TTY and then we have to reboot. Okay. So there you go. We're going to go and do this again in a moment with the other one. But I want to talk real fast then about these nodes, right? So you have all of these nodes running in your cluster, right? And the nodes within your cluster have pods running in them, and you can get the pods, and you can get the nodes, and you can get all of the different resources that are in this ecosystem. And there are many, and many that I won't have time to get to. But there's a really important one, and that is this controller concept, right? You have controllers. And a controller is the piece that kind of drives the state machine around in circles here, right? It says, look, this is what you have on your cluster, right? Here's our cluster with all the things, and they're all tied together. And this is what you want, right? Over here is this like what the cluster should be, some state. And this is what we're going to do to change and go there, okay? And we're not going to just change everything all at once. It's actually a very sane system in that it's able to make changes and not create situations where it decides that the cluster has the wrong network connections and then it rewrites all of them, right? Because this is going to take everything down. So that's part of the value of having an orchestrator is in being able to have these controllers, right? So these controllers are managing resources for us. When we deploy a new thing, I say, hey, I'm shipping this cool new application that I built. It's called Grafana, right? I'm going to ship up some Grafana, and Grafana's going to need to have some database back here, right? Then I just tell it, all right, I want this thing here. This is called a persistent volume claim, right? When I ship my Grafana application, I say, give me 2 gigs of memory. right? And then give me two gigs of disk space, and give me 2 gigs of memory, sure, right? And then it's the controller's job to decide how those resources get managed, where they come from, right? Where those are created. The orchestrator is moving all of this around, right? Last piece, and that's the piece that we're actually going to use if we get this last one booted up here. Let's try it, see if it works. Nobody's home. Did we forget to do SSH on that one, maybe? Maybe. Oh, Raspberry Pi is dead. Okay. Well, hold on just a moment. Let's check our Pi back here, and we'll see our keyboard is not plugged in correctly. And our Pi went to sleep. Let's get logged in, and I can get the actual IP address off of it. And that'll tell us if we're able to do it. The last concept I want to explain about this whole thing, and I'm sorry, many of you are well aware of these things, but this is the kind of thing that is just mystifying. There are so many terms to learn out there, and these are really the important ones, I think. There's one last one you'll have to learn pretty quickly that I'll go over in a moment. But we have the controller here, right? There's Kubernetes, which is an orchestrator, but then you have controllers manipulating all of these resources, right? And then you have another concept in Kubernetes named something similarly general, and that's called an operator. Operators, all of the things that I was talking about, like a persistent volume client, right? This thing where I'm like, hey, I want this data, and I want this thing, and I want to have access to like a Redis database or whatever I have, right? Data store. Then the operator is able to manipulate those resources that are different than the ones that exist under Kubernetes. So they're CRDs, right? Custom resource definitions. You can create yourself. And so when you install an operator, you're going to get, out of the box there, is you're going to get some controllers, and you're going to get some CRDs. And those custom resource definitions and those custom controllers can allow you to accomplish rather a lot of things without a lot of work. And I am very shortly going to be deploying the monitoring stack. So that's 173. The monitor is plugged into 173, and that means that this one, I think I've discovered the problem here. That's going to need an internet. Yeah. So we're going to plug that into the Ethernet cable. This was our little demo rig that I pulled off of the router to show you all. So I'll put it on this Ethernet cable, and we will boot it up. And I will leave the length of the video to the fine people at GrafanaCon to decide what is worth seeing, if any of it. But we have our last Pi to boot, and we're going to power this up, and it's going to be connected to the internet, and everything's going to be lovely. While I'm over here, may as well get this plugged on. I have all of this stuff. I showed you it was all strapped to this board here. That's entirely overkill. This is like a cooling board that I had sitting around. It's just got a little fan in the bottom, or a couple of fans, to cool the... I thought maybe it would be helpful. It gets me a couple degrees lower on the heat sinks, but I'm not actually getting that hot anyway because those cases have 2 fans built into them. It saves me like... I go from 41 to 43 degrees Celsius or something on the processor, which is not a big problem at all for the kind of overclocking that I'm doing. I only overclocked to 1.5 out of the 2.1 that I could have, and so they're all pretty tame. But again, this is more than double the actual clock speed, so you get like a 20% improvement by going to the 1500, I think I said, and 3 volts. The overvolting, right, is 3. It goes all the way up to 8. Don't go that high. There's no real reason to. But you can do your own research on all that stuff. Go read about it. There's not a lot of risk. You'll know that you have done the overclocking on your Raspberry Pi wrong when it stops working. And the disk system is this SD drive, and provided you don't roll over them with your chair, you can just reformat them and go again. So it's not that big a deal. We have a drive booted. Look at that. Looks promising. Let's try 174. Here we come. Drone 3. Drone 3 of GrafanaCon with no network file storage. We have our third one. Okay, so let's go look at Alex's project here, Ketchup. This is cool. I'm going to bring this over here for you all to share the joy. All right, so this is how Ketchup bootstraps Kubernetes right here, right? From your laptop, we get this kube config. We install onto all of the things out there in the cloud, and then you have a Kubernetes. See? Easy. For you, what this means is that you can actually run this curl command, and you should always read these scripts that you go and curl, please. I say, but I'm not going to do in this case. But you go and download this Ketchup installer. It's very easy to use. Once you have it locally, you can say Ketchup install, and you give it an IP, and you give it a user, and then you have a Kubernetes primary node. Like the boss comes out with just that one command. So when we are ready here, I'm going to go, let's drop down to a console on this one and see. We're going to go with a Ketchup install, and our IP address is going to be that first one that we had. I think I can actually just go with Prone 0 local. I'm going to use the IP address. There's probably something in that script that requires it to be an IP address instead. And if I remember, it was 176, and our user is pot, still by default. And we will see, yeah, I've got a password. It's not GrafanaCON. That's the good password on the key. I'm really glad that I didn't echo that to the terminal. That would not be the first time I had done something similar. Ruining the best version of the video we've produced so far, where everything with the original script worked. I cannot tell you how many hours I've put in just trying to get this much working. And I had the whole cluster out on the bridge. That was the build cluster, and I'm running, I had a Ruby app on there, and a little Go app, and a Python app that all talk to each other. And the goal is then to, over time grow and develop this presentation so that all of those things can be poked and prodded and we can see cool things happen in Grafana graphs. But when you are stuck in a boot loop of Raspberry Pi installing and Kubernetes installing, this appears to have worked. Get the nodes. Go wide. Get all of them. No. That's not what we wanted. Unable to connect to server because of something or other. Unknown authority. That's because Alex signed his own certificate? I don't care. There may be some install step that I'm missing. Oh, maybe I have to... You can always just try turning it off and on again. Okay. Let's try one more time to kubectl everything. I want to kubectl and get all the pods. Just show me all the pods. I have nothing. Surely there is a way to fix this thing. That I've not yet encountered this particular bug. But let's see. Here's our stuff. There are no other instructions here. Just do the thing. And it seems plausible to me that I need to have some certs installed. I know how to install certs on this thing here. I actually have that saved somewhere. Let me see what There are some certificates, I think, that I installed at some point for a cert manager. That sounds about right. But if I can't contact the cluster, that's not going to help me. So, mayhap, we will just go directly into the drone, and we'll try that. Oh. That'll probably help. All right, so far so good. It actually set a password. Oh, no, it didn't. I was confused by that because we are using our certificate. I'll be surprised if I'm asked for a... We're using our public key. I'll be surprised if I'm asked for a password. But not terribly surprised. I probably inadvertently made the password blank or something. So now that we did that, maybe we can kubectl some more. No, we can't do that because there are some certificates that we need to install on this thing that I don't have. So that is catch-up, and that is our installation story. And the next step is to go ahead and deploy probably the dashboard in Kubernetes, and then you would be able to see the dashboard show up and show you all of your resources, all of your pods and all of your containers, and get a general overview of your cluster and what your controllers are doing. So your controllers and their custom resource definitions, they are part of this operator technology. And you'll find a lot of operators out there that use Helm charts. If you find a Helm chart, that's like the top layer of the onion. And I'm sure there will be another one very soon. I guess actually operator is kind of, yeah. But the operators are about installing custom resource definitions and custom controllers to manipulate those resources. And you can do all kinds of cool things right out of the box because this operator concept gets to kind of impersonate a Kubernetes. It gets to do everything that a Kubernetes can do, and it gets to bring its own parts to the party and play with all of them. So you have a lovely day, and I really appreciate you taking the time to listen to my rants about Raspberry Pis and software and everything. And I am going to try and figure out what it is that I've done. I mean, it's the same image that I've installed over and over again for hours and hours, all night long. And I have this certificate authority problem. All right, that's that. I'll be in the chat, and you all can tell me what I did wrong, and I'll install it. And then maybe I'll fire up a video later, and we'll have Kubernetes on Raspberry Pis again. Rest in peace, my SD card.